Alright folks, so today we're going to be learning how to graph linear inequalities. So what we learned yesterday, we're going to take that and we're going to throw it onto a graph. I am going to really just go ahead and skip this first part. I don't know that it has a ton of benefit and it's just going to take up a bunch of our time. So we're going to focus on this section here, because this is really going to explain, and then on 1, 2, and 3 we can practice. So just like when we had something like this, right, and we wanted to get y by itself so we could graph it, we're going to do the same thing here. We are going to solve the inequality for y. You know what? I'm going to work in a different color. We're going to solve our inequality for y. And then use the y-intercept and slope You know what? Sorry guys, this pen I'm using is just terrible. I'm just going to use my finger. Okay. We'll use the y-intercept and slope to plot points on the line. So it's basically like when we graphed lines, linear functions. Now this new part, drawing and shading. We'll see how this works out in a minute. But when we draw our line, instead of when our linear functions we always drew a solid line, now we're going to have solid lines when we have a less than or equal to and greater than or equal to symbol. But if I have less than or greater than, I'm just going to dash the line. Kind of like when we had something like this and we didn't shade the circle for domain and range. If you remember that, it's very similar. Now, shading. If it says less than, think about it. If y is less than, and I'm going to use this graph as an example for a second. If it says y is less than 2, and I'm looking at this 2, that's the y value, right? It says y is less than 2. So I'm going to want to include all these numbers down here. Negative 2 is less than 2. Negative 4 is less than 2, and so on, right? So I'm going to color in everything down here because the y's are less than 2. Whereas if I had y is greater than 2, I start here at 2, and here's up here, 4, 6, 8. That's where all my y's that are greater than 2 are, so I'll shade above that line. So coming back up here, and just copy this down for now, we'll see it in practice in a minute. If it says less than, you shade under the line. If it says greater than, you shade above the line. If it says less than or equal to, it's still under the line. And if it says greater than or equal to, it's above. Okay. We'll come back to this part in a second. Let's ignore it for now. Now it says, in 1 through 5, graph each linear inequality. And then we'll check our solution. Let's do number 1. Y is greater than x plus 3. So the first step they said up here is going to be, since we don't have to solve our inequality for y because they already have y by itself, so I'm going to use the slope and the y-intercept to plot points. Well, my y-intercept is first, right? My y-intercept's 3, so I'll find 3 on the y-axis and I'll plot a point there. And then I'm going to use my slope, which in this case, what's that invisible number in front of x? It's the ninja number, it's 1. 1x, right? So now this 1 is my slope, but I like to use rise over run. And to do that, I have to have a fraction. So I will put it over 1 so that I then have my fraction, right? So rise 1, run 1, it would be here. So now I've used my slope to rise and run to a new point. Okay, now I'm going to get this out of the way so I can write my line. So now, if I want to make my line, it's going to look something like this. And mine's not perfect, but it's okay. Now, did I make a mistake? Well, I made this line solid without checking if it should be solid or dashed. So let's see. Based on this symbol here, it is a greater than symbol, and it is not equal to. It doesn't have that line. So let's go look. For a greater than symbol, which is right here, I need to dash my line. So let's go back and let's make a dashed line instead. Oop. There we go. So now I've accounted for the fact that this is not underlined. And now I have to figure out which way to shade. Shade the grid. It says either under the line or above the line, depending on the symbol. I've got a greater than symbol, so I will shade above the line. And does that make sense? Are the y's up here greater than this y right here? Well, yeah, 8 is greater than 3, 6 is greater than 3, and so is 4. So that leads me to believe I've done this right. Cool. Okay. Now it says check. It wants us to check with a number by substituting an ordered pair from the shaded region into the original inequality. So they're saying pick any point over here at all that you want and just make sure that it works. I'll do this point right here, whatever that is. So that's -4 and then 5. So -4, comma 5. So let's check. We're going to plug this -4 in for x and this 5 in for y, right? Which makes sense because this is my x and this is my y from that point. So now, if I try that, and bring this equation down here, y is greater than x plus 3. Okay. And then I got to plug in my point here, -4, 5. So 5 was my y. Bring this down, and then for my x, I had -4. And then bring down my plus 3. 5 comes down. -4 plus 3 is -1. Is 5 greater than -1? Well, yes it is, so we know we're right. Good job. Okay. Now, I am going to skip checking on the next two just for the sake of time. You can if you want, but you don't have to. Now, for number 2, I have y is greater than or equal to -2x minus 4. Again, let me look at my steps. It says solve the inequality for y, but they've already done that, so I don't have to do that here. What's step 2? Use the y-intercept and slope to plot points. Well, let's see if we can do that. Use y-intercept and slope to plot points. Y-intercept first, so that goes at -4 right down here. Okay, and then -2x, so this here is my slope, right? So if I want to make it a fraction, I'll make it -2 over 1. Always divide by 1 to make it a fraction if it's not already. Okay, so now I have a rise and a run. But I'm going to clean all that up. Okay. So my rise is -2. So I go up. Oh, I'm sorry. It's -2, so I have to go down, right? 1, 2. And then my run is 1. So I'll go over 1. There's my new point. So now that I have my second point, I can connect those two guys using a line, right? And let's double check and make sure it actually should be a solid line. So I've got this greater than or equal to symbol. Let's go check. For greater than or equal to, I do indeed have a solid line. So I know that I was right. I don't need to do one of these dash lines up here. So now, I just have to figure out whether to shade the top part or the bottom part, right? Above or below the line. Again, using that greater than or equal to symbol, let me go look. Well, it says for greater than or equal to, you shade above the line. So we'll do that. Shading above the line would be here. Like I said, in the interest of time, we're not checking today. So we are done with problem 2. Problem 3 says y is less than negative 4. Well, if y is less than negative 4, there's no m or x, right, in here. There's just that b value. So this is going to be pretty easy to graph. So negative 4 is down here for my y-intercept. And then hoi vux, right? Remember hoi vux? Well, this is a y equals equation, so it's going to be the hoi part that I use, which means I have a horizontal line. Like that. Does that make sense, guys? That if I have y, not y equals in this case, but like y is less than negative 4, it's kind of like when I had my y equals negative 4 equations, right? So it's a horizontal line at y is negative 4. But in this case, I have a less than instead of an equal, right? So let me see, should this line be solid or dashed? Let's find out. It's that less than symbol. This is the one that matches, and it has a dashed. So that's what I want to draw. If you already drew your line, that's fine. Just erase little parts like here. See how you could erase there, erase there, erase there, there, and there. And then you would have a dashed line. But I'm just going to redraw it because my application won't let me do that. There you go. So you have it. A line at y is negative 4. But now I have to figure out whether to shade above or below that line. This symbol matches this symbol, and it says under the line for that case, so let's shade under the line. There you go. Okay, so now you understand how to graph these equations. Okay, so let's go to the back side. And now it wants you to graph equations again. But we don't have y by itself. So we're going to have to figure out how to do that. Here, I would take, well, I want to get y by itself. So kind of like when we had to do equation or rearrange equations to solve for y with an equal sign, we're going to do the same thing, same steps. Before I handle this 3, I'm going to handle this 2x. So let's cancel out that minus 2x, minus 2x. These go. 3y comes down, less than or equal to 18 minus 2x. Then divide by 3 to get y by itself. Y is less than or equal to 18 divided by 3 is 6 minus 2/3 x. Okay, ignore the check part, we're not doing that. Now, to graph this again, you can rearrange it if you want and put it in truly y equals mx plus b form if you like that. There you go. So now it's easier to spot where my y-intercept and my slope are. But if you were happy with this version, then you can leave it like that if you know what to do. But you use, first again, your y-intercept. So that is 6 in this case. So 6. And then negative 2/3 x. So we go, this is my rise, is that negative 2. Go down 2. And then my run is that 3. Go 1, 2, 3. Oh, it kind of messed me up. And then this is your second point, and you make your line. But let's check if that should be a solid or a dashed. Again, we've got this less than or equal to line. So less than or equal to has a solid line, so we're good to go ahead and use that. There we are. Last thing, figure out if we shade above or below. Less than or equal to, we shade under the line. So let's shade under the line. There you go. Okay, now let's pause and let's go back and look at this. It says the solution set of a linear inequality, so the things that are solutions, the things that make that equation true, are all ordered pairs in a graph's shaded region as well as on the line if the line is solid. Points on a dashed line are not included in the solution set. So when I have this solid line, that means that every point on this line is included as a solution. They are part of the overall solution set for this inequality. So now let's try one more. This one has a weird extra step. We don't see this often, but they've got the 2y. They've got the y on the right side of our symbol. If I want it to be y equals, or in this case y is greater than, I've got to move that sucker over, right? So let me do that. To cancel out 2y, I do minus 2y on both sides. Then, when these go, I do 6x minus 2y is greater than negative 10. Then I've got to get this x out of here so my y can be by itself on that side. Do minus 6x minus 6x. And then negative 2y is greater than negative 10 minus 6x. To get it by itself, I have to divide by negative 2 on both sides. And so these cancel out, and y, oh, but looky here. Remember, if I divide by a negative number, as I just did, I have to flip my sign. So I'll put that here. If I divide by a negative, I flip the sign. Okay. Going back, so I flip my sign, and now negative 10 over negative 2 is going to be positive 5. There we go, 5. And then negative 6 over negative 2 is 3, and then x. So I'm going to make you guys actually pull your y-intercept and your slope from this. What's your y-intercept? Don't get mixed up by the fact that the x is over here. Your y-intercept is still that number by itself. Sorry, I didn't mean to delete my box there. Your y-intercept is still the number by itself. So my y-intercept is 5. Plot that here. Then your slope is 3, which is the same as 3 over 1. So now I have a rise and a run. My rise is 3. 1, 2, 3. My run is 1, 1. There's my line. Let me make sure that it's actually solid before I do that. So let me check this less than. Oh, good thing I checked, because for a less than symbol, I have a dash line. So let's dash that line instead. There you go. And for a less than symbol, I shade under the line. So let's do that. Shading under the line would be here. All right. Now, write the inequalities shown on the graphs. Well, I know that it's going to be like a y, some sort of symbol here, something, and then mx plus b. Right? So let's figure out what those numbers need to be. My b for this one equals, well, it's 1 right there, right? And then my m, let's find it. Let's find another clean point. I'm going to use this one here, and I'll rise and run. 1, 2, 3, and 1, 2, 3. So 3 is my rise, and 3 is my run. So it's 3 over 3, which is also equal to 1. So my y, I'm going to leave the sign out right now. We'll come back to that. We're going to put 1x plus 1. You could also just erase that 1 in front of the x, because it's a ninja one, right? It doesn't really need to be there. Okay. And then I have to figure out my symbol. Well, it's a dashed line, and it's shaded above the line. So let's figure out which symbol has a dashed line and is shaded above the line. Dashed line would be one of these two. Above the line would be this one. So I'm going to use this symbol right here, that greater than symbol. There we go. And then for my second one, my b, excuse me. So again, what's my y-intercept? Well, my y-intercept is at -1. So let's do -1 for b, and m. Let's rise and run to a new point. I like this one. It's a clean point, so I'll use that. 1, 2, 3, 4. 1, 2. Oops, sorry. 1, 2. So 4 and 2. This is my run because it's horizontal. This is my rise. So rise over run would be 4 over 2, which is also just equal to 2. So I'm going to bring those numbers over here. And I'm going to put y. I'll leave the symbol out for right now. But my slope goes here, 2x plus, and my y-intercept. Oh, my y-intercept was -1. So I've got to do -1, right? There you go. And then my symbol, well, it's a solid line, and it's shaded below the line. So let's figure out which one is a solid line shaded below the line. Solid line would be one of these two. Below the line or under the line would be one of this, or this one rather. So it's that one right there, less than or equal to. There you go. And then it says, Daria believes that 2, 3 is a solution to both inequalities. Do you agree? Well, 2, 3 is here at x is 2 and y is 3. I'm going to actually pick a different color. So it's right on the line there. Sorry, I'm not writing this very clean, am I? There you go. It's right there on the line. And it's also over here, right there on the line as well. So let me think. I know that solid lines are included in the solution set. Right? It says on the line if the line is solid. But it says points on a dashed line are not included in the solution set. So that point is on a solid line and included for B, but it's on a dashed line and not included for A. So I'm going to say that no, Daria is wrong because that point is not included for A. There you go. All right, good. Okay, now 7, it says Bernice graphed the inequality right here. Would the shading on Bernice's graph cover the origin? Hang on, guys, I'm just thinking real quick, because this seems like something that I would certainly want to graph before anybody expected me to comment on that, and they didn't give you room to graph. You know what, I think we're just going to skip that question because I'm not liking this question. I would want to be allowed to graph it before I commented on that, or at least have the space to work it out by hand. So let's skip 7. And then, here we go. So now we've got this equation. So they graphed it with an equal sign, keep in mind. They didn't graph an inequality, they just graphed the regular old line. Is 2, 4 in the solution set of 3x minus 5y is greater than 15? Well, if I was graphing this, the things I'd have to change, let me look at this, whether it's a solid or a dashed line, and where it's shaded. For a greater than symbol, the greater than symbol has a dashed line and it's shaded above the line. So it's a dashed line here if it's greater than, and it's shaded above. Well, 2, 4 is way up here in the shaded area. So yeah, I'm going to say it is in the solution set. Yes, because it's in the shaded area. There you go. And then last thing, the graphs of 4 linear inequalities are shown. Fill in the blank fill in the blank with each correct inequality symbol. So now it's just a matching game between these 4, and this bank up here. So your job is going to be to figure out which symbol makes sense with each one. In this case, it was a solid line, and it was shaded above the line. So if you were to try and look at your notes up top, that section 2 and 3, you would see that it's a greater than or equal to symbol that makes sense here. Here, it's dashed, so I know it's not going to be underlined. It's going to be one of these two, right? Because my solid lines are the ones where I have my less than or equal to or greater than or equal to. So it's not one of those. And it's shaded below the line where all of my y values decrease. So it's the y values that would be less than this one right here. So if the y values are less than that, so I'm going to say y is less than. Oh, you know what? I'm just going to leave that there. And I'm going to put less than. Over here, it's dashed again, so I'm going to say it's one of these two symbols, and it's all the y's that are greater than this one right here. So I'm going to say y is greater than that equation. And then here, we've got a solid line, so it's going to be either less than or equal to or greater than or equal to. And it's shaded below the line. So these are all the y's that are lower than this point or less than. So I'm going to say y is less than or equal to. Okay, hopefully that makes sense. If you have any questions, if you're in my class, ask me. If you're in somebody else's, ask your teacher. Hope you enjoyed the video. Thanks, guys. Bye.